Okay, we're recording. All right, so this is example B from day 31 notes. It is giving you, let's see if we can adjust this. It's giving you an angle and two sides, and the reason I know that this is ambiguous is because when I draw it, the angle is not between the two sides. That would be side angle side, which is used with law of cosines. So if we go to draw this, now here's another thing that I answered a lot on the last review day, was the order of A, B, and C in your triangle labeling does not matter. If you try to make it go in alphabetic order A, B, C every single time, then what's going to happen is the side that can move is going to change every single time. So do not recommend doing that. I've had several conversations with people about how the side that they thought was changing was not the side that was changing because they labeled it backwards. What I do is always label the same angle and the same two sides with whatever was given. That way I know which side moves each time. So the angle that I'm given is always going to be the bottom left, and I only label it with whatever letter was given. Whether that's A, B, or C does not matter. This is a C. Then the side directly across from it should be the same letter. So this is also side C. And then I label my other given side on the top left. Now the reason I do that is that this right side will always be the one that can move and creates the isosceles triangle. I don't have to guess or check which side moves each time I do a new problem, which takes up a lot of valuable time. Okay, so this is what we have so far. This is angle B, since that's side B. And now normally what we would do is go ahead and solve for angle B and then build the isosceles triangle and test whether that angle is possible or not. That's how we would test for a second triangle. Here's another method. Again, do not have to use it, totally optional. We can use the law of cosines to check whether this has one or two solutions or none. So what we'll do is we'll set up the law of cosines. Remember, the cosine formula only has a single angle in it, so we're going to use the angle that we have here as that angle. So the formula I'm going to use is cosine of C, since that's the angle I have, which means C squared goes on the left side, and then A and B go in the middle. So A squared plus B squared minus 2AB. Okay, now filling in everything I know, you'll see that we have a single variable that's unknown, but it shows up multiple times in the equation. So C squared is 10 squared, A squared we don't know, okay, so I filled in everything that I've been given, and now we're going to simplify this a little bit by just plugging in these numbers to get, simpler versions. So 10 squared, A squared just hanging out by itself, 12 squared is 144, and then this is 2 times 12 times cosine of 50 with an A in there. So I'm going to do 2 times 12 times cosine of 50. A. Okay, so I put those dot dot dots because I'm keeping that number in my calculator so I have an exact number, but you can just round it to like 15.4 in your equation. Now the next thing I noticed is that I now have A in two places, and one of them squared, one of them's not. So this is actually quadratic, with A being the variable. So in order to solve a quadratic, you move everything to one side, set it equal to 0. We're going to move the 100 to the other side. Okay, so there's our quadratic. Now, quadratics are great because they either have no solutions, one solution, or two solutions. So this quadratic is actually going to tell us how many different triangles we have, because it's basically giving you all possible side A values. If there are two triangles, you'll get two different A values, and that builds your two different triangles. So if we go to solve this, now if these numbers are not nice, which most of them won't be, you will have to use quadratic formula, which is the place where I lose a bunch of people. They're like, I'd rather just do it the other way, which is totally fine. This is just two different, totally different methods, so whichever one makes the most sense to you and you think is clearest. If we solve this using quadratic formula, we have negative b plus or minus square root b squared 4ac over 2a. And inside that square root is squared minus okay, So now we're going to check our two solutions, and if they're both real numbers that are positive, then that means we have two separate triangles, and we now know both of their dimension A's for both triangles. So 15.4 plus 7.82 divided by 2 gives me one of the side lengths as 11.61, and for the other one, if I subtract the 7.82, we get 3.79. So that means we do actually have two triangles in this case, and I know both side A dimensions at this point. So if I go back up and draw my triangles, the second one is going to be the one where you would have moved this side in, so it's going to have the shorter side A. So my second triangle looks like this. It has the same given information, and I already know side A is 3.79 because I solved for both at the same time. So now your job is to solve for that angle B and angle A, but now you already know that there's two triangles and you already have the side A lengths. Conclusion.